Hi, I'm Marco. And for those who don't know me yet, I'm a technical sound designer. And as you have probably already recognized from my strange pronunciation, yeah, I'm from Germany. Today, I want to give you a quick overview and rundown of my Wise project that I did for the New Year New Skills Game Jam hosted by Bitter Sales. This was a 7-day game jam, and the theme was building connections. Me and my team chose a 2D top-down adventure-style game, and the overall story idea was that it took place in a previously devastated world by an unknown cause, and the player has to find and unite or reconnect 5 ancient rune stones that will gradually transform the destroyed landscape back to its original state. And he will do so by solving different puzzles. The final build, of course, didn't feature the whole game. It was just a little demo of our game idea, and it featured the main menu and early gameplay of the first ability and 2 puzzles in 2 different locations, a pause menu and a credits screen. We chose Unity as our game engine, and as previously already mentioned, I chose Wise for the audio implementation middleware, and I use Reaper as my audio workstation. So our team formed a few days prior to the start of the jam, at which point the theme of the jam has not yet been unveiled. But despite this fact, we still wanted to plan a little bit ahead and agree on a style of game that we wanted to make. And based on this idea, I planned a basic project structure for my Wise project, with different game syncs, an actor mixer hierarchy, container structure for sounds that I'm probably going to need, like footsteps or ambience, a basic bus structure with the AUX Sends, and some basic events that I would probably going to need to make the game or the sound in the game function at a basic state. But before I started setting up the basic Wise project, I defined some audio integration principles that I should follow to make the project a success in this very short time period. So my first principle was to get most of the Wise systems and game engine interactions functional with placeholder sounds and do the sound design at second place, because I felt like good sounds are pretty useless if they are not properly played back or not even played back at all. So set up the Wise project and the interactions first and do the good sound design second. My second principle was to use as few different events and in-game scripting as possible, and to do the most sound logic in Wise and not in the game engine. And this resulted in as many game sync driven sound changes as I could possibly do to make it more handy to use, control and debug during development. Since our game idea included a playable character that the player could navigate through the world, I set up some basic player-related game syncs that I thought would definitely be needed. So I put up a ground surface type switch where I put all the different ground surface materials that came to mind inside. Didn't know if I would need them all, most definitely not, but I thought better set them up early and have them and don't need them. Yeah, so they're there. The other thing I put up was a very similar switch. It's a hit surface type switch where I thought if we had some kind of weapon, like melee, a sword or something, that I would need a hit surface type switch to determine what kind of target was hit and adjust the sound of the hit accordingly. Another thing that would, in my mind, most definitely be needed is a player health RTPC. It's just an RTPC that goes from 0 to 100. And to make it a bit more handy to set up sounds that will be adjusted by the player health, I also set up a switch group that's called the player health switch, which is in itself controlled by the player health RTPC and has many different states that are set by different health amounts. Another game sync that I set up really early in the development was the game state. Although the contents of the game state changed over the course of development, but I wanted it to function as an indicator in which state of the game we are currently in. So if we're in the main menu, if we are in the intro scene, outro scene, in the shrine number 1, pause menu, whatever. So I could then adjust many different things according to this game state. So for the last two, in my mind, very important game syncs, the first one is the area type switch. The same as for the surface type switches, I set up all of the possible areas that I could imagine because I didn't know at this point in time what our game would look like. So what kind of areas would it feature? So I set them up all at once. And I have them if I needed them. The other thing was that I put up 3 RTPCs for the menu sliders because I wanted a volume settings menu for the master volume, the music volume, and the SFX volume. And these are all each controlling their respective buses. So the master volume RTPC is obviously controlling the master audio bus. The music RTPC is controlling the music bus. And the SFX bus is controlling all of my world audio bus, which are all of the sounds that are present in the world, and thus SFX. But I also added the SFX RTPC to the UI bus, since it is not part of the world, but it should also be controlled by the SFX volume slider. So since we are already here in the master mixer hierarchy, there's just not much to see here. It's just a very basic structure divided by non-word and word sounds. The non-word is the music and the user interface, and the word sounds are everything else like ambience, enemies, objects, player, and all of the environment aux buses. These are the environments that were finally in the game. And I set up a large and a small sounding environment reverb for these areas that I could then encapsulate different parts of the map to sound differently depending on their size. So this brings me directly to my actor mixer hierarchy. So let me just pull this a bit up here. So I tend to make a similar hierarchy on my mixing bus setup and my actor mixer setup. So I instantly know where everything is and how everything is connected. It makes sense to me. So I also divided my actor mixer hierarchy into a non-world and a world actor mixer. And in the non-world is only the UI sounds, and in the world actor mixer are all of the other sounds except the music, since this is in the interactive music hierarchy. As for the ambience, I wanted to set up one single switch container and one event that is started when the game starts to control the ambience of the whole playthrough just with this one instance. So I set up the ambience area type switch container. In here we can find many different blend containers and single sounds for the different areas that are present or not present in the game. So these 3 are the ones actually used in the final build of the jam. And they were initially intended to be blend containers because of some random sweetener sounds, but there wasn't the time to implement them, so they are basically just a blend container with one single sound in them. But they are controlled by the area type switch that I showed you earlier. And I set up the continue to play across switches and a fade in and fade out time. So if you switch areas during gameplay, yeah, the ambient sounds are gradually and nicely fading in and out to give it a very smooth transition between the areas. The next thing I want to show you is the player movement. And for this, we are heading over to the player actor mixer. And in here, we can find the player movement actor mixer. And below this is the player Foley random container and the player footstep surface type switch container. So the surface type switch container is controlled by the ground surface type switch group that I showed you earlier. And it contains random containers with only 2 footstep variations at this point, because I used Wwise with the 200 asset cap in place, and I didn't know at this point how many media assets I'm going to have, so I opted to only use 2 footsteps, one for the left, one for the right, and make a bit of volume randomization and pitch randomization to not make it sound like it's only 2, but yeah, save on assets that are actually implemented in the game. As for my color codes, the green ones are the ones where I already imported audio assets for, and the red ones are still empty and yeah, not ready to be used. Besides that, I'm using colors for all the different kinds of sounds. So the player gets a bluish color, objects orange, and so on and so forth. But on the most bottom level, I'm using this red and green color palette to immediately show me what is ready and what is not. But getting back to the player movement, these 2 containers are actually called inside one single event. Let me just head over here quickly. So here's the play footsteps player event, and it triggers both containers at the same time. But I've got a state control on the player footstep switch container, which introduces a initial delay for the playback of the container in regards to what movement state the player is in. So when he's running, the delay is actually 0.1 seconds, and if he's walking, the delay is 0.15 seconds, to space the Foley and the footstep a bit more out to make them clearly distinguishable from each other. But the actual footstep interval isn't defined in Wwise. It is triggered inside Unity with a script, because I initially wanted to realize it with animation tagging, but the sprite animation was so short and so fast that it wasn't really feasible to do it this way. So I wrote a little script with a definable, cooldown time that would trigger the footsteps according to what movement type we are having at the moment, and triggering them in this succession. Next, I'd like to show you my interactive music setup. So let's just minimize this and get over to the interactive music hierarchy. I got some really nice music composed by Kate Tavasoli, which I will link in the video description for you to check out. Really nice work on this one. And the concept was similar to the Ambience setup, that I just wanted to have one event that is posted at the start of the game, that is present on a persistent game object to be accessible for different game calls. And I used a music switch container that is controlled through a game state switch. let me just show you this. So we have this interactive music switch container. Here are the different switch states, and inside the switch container we have got some different other containers. Some of those are sequence containers, or playlist containers I should say, and some are just single music pieces. And these are all connected to different game states, which are then played back at this point in the game. So starting with the main menu, this is just a simple playlist container, which has the music piece in it. So this piece was originally composed as one single music piece and was not intended to have any loops in it. So I just imported it into Reaper, set up the right beats per minute, and created the looping points myself, cut it into different pieces with some overlaps, so fade in and fade out would work nicely. And I just set up 2 different containers inside this playlist. The first one is just a sequence continuous container, where the build up of the music piece, which is not really loopable, is played at first, and after that directly follows the first main loop part of the music piece. And after that we have a random continuous container that is looping infinitely, which has all of the other music loops inside it that are all equally possible to be triggered. The only one exception is the fade out that has a really small percentage to be triggered, because I wanted to have the possibility that the music would fade out completely, stay away for a kind of random time, and then come back at some point in time. So I thought this would be a really nice dynamic, but I don't want it to be that common, so more like a rare occurrence. So I opted to weigh this really low so it doesn't happen all the time. To ensure that the transitions between the different loops were as seamless as possible, because the loops were not originally designed to be loops and to be looped from the end back to the beginning and so forth, I defined as many different transition possibilities as I could, to really make sure that every and each combination from one to the other loop is really seamlessly, and it is not obvious that the music piece is not initially designed like this. So speaking of transitions, if you press the play or new game button in the main menu, there will be a transition segment triggered that is specifically designed to cover up the transition between the main menu theme and the theme of the first level. And also, if we were to go back from the first level to the main menu, I also designed a little transition segment that is just empty, so there's a little pause between the fade out of the level theme and the fade in of the main menu theme. So you only see here the Shrine 1 theme. Actually, the theme for the second puzzle exists, but there was really no time to implement it. So sorry, Kate. Really nice work on this one too. I'll definitely put it inside the project, although I don't feel like anybody will hear it then. Last but not least, I want to show you the music for the first level, which is the Shrine or 1 theme. So this was designed a little bit differently. So the loops were pretty much the same. They were not set up initially to be loops. So I used the same method as before with the main menu theme. So I designed them myself and set up the various different transitions to make them as seamless as possible. But the special part of this music piece is that it is composed with different layers of intensity. So there is a base layer that is really calm and doesn't have much intense music layers above it. And there are 3 different more layers of intensity, which can be controlled through a game sync. That is actually a switch, which is controlled by a RTPC. And so I set up each music loop in a switch track, which then can be switched depending on the shrine connection count RTPC. So you have to connect a number of shrine connections in a puzzle to make it to the next stage. And depending on how many connections you already have made, the music will change and become more intense the further you progress inside this puzzle. So just before heading over to the game to show you a little playthrough of it, some quick words about bank layout and optimization. In regards of the bank layout, I decided to go with 3 banks in this instance. The main bank, which almost inherits all of the sounds except the music and the player sounds. Normally I would split them up even further depending on area you are in, but I didn't feel like it was necessary and would only complicate the work even more if I did so. So I just decided to do a music bank to do some other compression stuff on it and have it all nicely packed together. Have the player in a separate bank because I would not need him in the main menu, although I didn't need all the other sounds as well. So yeah, it's just force of habit to have a bank for the player himself, and yeah, just crammed all of the other sounds into the main bank. Quick word on optimization. I didn't really do a lot of optimization because the scope of the game was so small and there wasn't even that much time for optimization either. So I just did a little basic compression for the biggest sounds in the game, which are the music and the ambience. You can see the size comparison over here. So I brought down the music bank from roughly 110 megabytes down to 8.5, and the main bank went down from around 40 to 7.5. It's not that necessary, but in terms of Git, it was a real. It made a real difference because Git only allows file sizes up to 100 megabytes if you're not using Git LFS, and Git LFS made problems with our project. So this really saved me in pushing my stuff to the repository to finish the project in the end. Okay, so we switched to Unity, and I want to talk about the main difficulties I faced during the project. There were a few, and some of them were unexpected, some of them were expected, but I'll just talk you through them real quick before we get into the playthrough. So the main problem at first was we were using a character controller from an asset pack, and I had to find the connection points in the character controlling scripts, which were very many different scripts interacting with each other. And I had to find the points and the values to get to post my Wwise events for the footsteps, for the player interaction, and all of those stuffs. So I decided to write a little helper script for the player himself that would get all the different states and values from the other scripts to control my Wwise events. Another problem was that I didn't foresee is that Wwise and true 2D environments really don't like each other that much, because most of the Wwise components in Unity require 3D colliders or rigid bodies to function. So this is especially true for all environmental aware AUX Send detection. So if you use Wwise environment to dynamically switch your AUX sends on your sounds to the accordingly correct reverb that you have in the game. You have to set up a 3D collider, and it only detects AK game objects with a normal rigid body on it. But since our character and all of the world only use the 2D equivalents of the rigid bodies or the colliders, I had to put a separate child game object to every single thing that I wanted to react to the environment, be it stones that are destroyed, be it the character, the footsteps, or his abilities, or anything that needed to be environment aware had to have a 3D configured child game object to it. That was essentially the only solution I found, because you cannot combine a 3D collider and a 2D rigid body on one and the same game object. That's not possible in Unity. And the last one that was a bit complicated at first, but not so complicated afterwards, was to get the footstep detection working with the tile maps that we had. Because the tile maps were originally just designed to be one layer with all of the tiles painted on it. But that would make it impossible to detect the different surfaces with my surface detection script, which relies on a raycast collision detection, which then gets the tag of the collided game object, which in itself is tagged with the correct name of the surface you want to be triggered. So the tags are all in conjunction with my switch setup, so the names are all the same. And my script just looks for the tag, sees, okay, it's grass, and then it sets the switch to grass. But if it's all one layer, it isn't possible. So the solution was essentially to split up the tile map into multiple tile maps, one for each individual surface layer that we wanted to be represented in the footsteps. So if we had a grass area, we would make one whole grass tile map and then make a separate tile map for all the ground decorations, like stone tiles, for example, and tag them, for example, cobblestone or stone or whatever. And if we layer these together, then we can indeed detect the different surface materials to trigger the right footsteps. Okay, so to close this not so short video up, I'll just give you a small playthrough of the game we created, show you all of the elements that have sound that I've done, and enjoy. Yeah, so this was the little playthrough of our game we created during the New Year, New Skills Game Jam. And yeah, I'm quite happy with the result that I could contribute to this little game. It was quite challenging using Wise for this scope for a game and this short time frame. But I definitely learned some things, which was, of course, my main goal for this jam. And I had much fun doing it. And yeah, I hope you enjoyed this little playthrough and this video. And thanks again to the team who was working with me on the game. And if you have any further questions, comments, or whatever, just post them in the comments and I'll read them and, of course, reply if there are any questions. Thanks for watching and yeah, see you next time.